Hello everyone. In this topic, I will discuss with you the concept of motion. And in this, along with this, I will discuss few quantities just like distance, displacement, speed, velocity, acceleration, which are required to describe the motion of different types of objects. After that, we shall also take up graphs. How can we represent the quantities on a graph and how can it be used to calculate few important quantities required again to describe the motion. We will also derive equations of motion, again very useful to describe motion. Rest and motion. Very common words that we use in daily life. Sun rises in the east and then throughout the day it moves from one end to other, sets in the west. Moving train, moving car, moving bike, all these terms we use in everyday life. What is common in all these? The objects change their position. At some point of time you see them at one place, after few seconds they shift to some other place. Then we say that the object is moving. Sun is moving, car is moving, or any moving object. I give you a situation. Suppose you are sitting with your sister in a car which is running at a speed of 60 kilometers per hour. Now, your sister is not changing position with respect to you. As you observe her, she is at the same position every moment. But when you look outside, all those objects which are on the ground, which are outside, not moving with you, they appear to move in opposite direction. You can see the trees, the fields, they appear as if they are moving in opposite direction. Now here, if we apply the same criteria that the objects changing position, we say that they are in motion. So whenever an object is changing its position, it is said to be in motion. We said that. Now in this particular case, your sister, is she in motion with respect to you? Or are you in motion with respect to her? Or your car is moving with respect to those outside, or the trees are moving with respect to you? Actually, there can be many answers to this. Few of them may be, your sister is at rest. If you are the observer, you are at rest if your sister is the observer. You are moving with respect to all those who are standing on the roadside. The trees are moving when you are the observer. All these answers are correct. So what does it mean? What can we conclude from it? It means motion is not absolute. Absolute means which is same for all. So an object, your sister is moving with respect to the person standing outside on the road, but she is not moving with respect to you. Trees point of view, you are moving, and from your point of view, you are not moving, the trees are moving in opposite direction. All these answers are correct. So motion is a relative concept. It's not absolute. Relative means an object which appears to move to one observer may be at rest with respect to some another observer. So motion means change in position of an object with respect to an observer. We should include this. So an object is said to be in motion if it changes its position with respect to some observer. If it is not changing its position, then it is at rest with respect to that person, though the same object may be in motion with respect to some another observer. Right? So this is what we mean by motion. So motion is relative. Relative means it is observer specific. Okay, now types of motion, if we go on that. A body is moving along the road. You are in a car moving on a highway with a speed of say 60 kilometers per hour. This we say translational motion. Translational motion means you are moving this, or maybe like this. Even this is translational motion. This is motion along a line, a straight line. This is a rectilinear motion. Along a curve, not a straight line. This is curvilinear motion. So both are translational. Translational motion is along a line. When it is a straight line, rectilinear motion. It's a curve, then it is curvilinear motion. Straight is, I gave you an example that when you are in a car on a highway, it is rectilinear motion. And on curve, when you are in a car and you are going up a hill, then it is curvilinear motion. Or you take an object and throw it at some angle, so it will make this type of path. Then this is again a curvilinear motion. Another example may be rotational motion. Rotational motion is, I take this object and then instead of moving along a line, it's moving around a line. So it's a line and I cause this. This is moving like this. Fan. So it's moving like this. So this line around which the body moves, we call it the axis of rotation. So motion along a line, translational motion, straight line, we call it rectilinear, curve, we call it curvilinear. If it is around a line, we call it rotational motion. And another type may be oscillatory motion. You might have observed the pendulum, or I can take any object, say, okay, it's a charger, and if I, so this is oscillatory motion. The body moves to and fro about a position. This, wherever my finger is, it can be called a mean position or central position. It is going on one side and then on the other side. To and fro motion, we call it. To and fro about a position, which is called mean position. So we call it oscillatory motion. So translational, rotational and oscillatory, major type of classification. Okay. Now, a very important quantity when we describe motion. Distance. We all are familiar with this. In the morning you go to school, suppose it is 5 kilometers from your home, and then you return from the school, then total distance covered is 10 kilometers. I ask you, how much have you traveled? The answer is 10 kilometers. If I ask another thing, how much have you displaced? What should be the answer? Displaced means wherever you were initially, at the end, if you return to the same point, you are not displaced at all. But if you are not at the starting position, you are somewhere else, then you will see the displacement in terms of only the distance of final position from the initial position, not the total length of the path. So that accordingly we will define one more quantity. It is displacement. So distance is the total length of the path covered, and displacement is actually the straight line distance between the final and the initial position. Actually this takes into account the direction. We can say distance covered by a body in one specific direction, then it is displacement. Both will be measured in meters only if I am taking SI system. And see what I mean when I am saying distance covered in a specific direction. Take few examples. Example 1. A body starts from A, it goes to B, and then it returns. Suppose this distance is 1 kilometer. Then distance is 2 kilometer. Displacement is 0. Because final position is same as the initial position. You have to see the distance of final position from the initial position. Okay, take another example. A body starts from here. First it goes to B and then it goes to C. And let me take east, west, north, south. Say it is 1 kilometer. And then it is 1 kilometer. Total distance covered is 2 millimeter. But if I ask you what is the displacement of the body, then it is not 2 kilometer because it has displaced actually 1 meter towards east and 1 meter towards north. So now what is the net displacement? We have to find out this value using Pythagoras. This is the displacement. So it is telling us, if this angle is theta, that the body displacement is AC at an angle theta from this direction, from east. So I can say north of east. So if you know this Pythagoras, so AC will be under root AB square plus BC square. So it becomes under root 2. So I should say the displacement is root 2 meters at an angle theta from east towards north, or at an angle theta north of east. We can find out even this angle. Okay. Take some other example. Let me take a body moving on, say, circular path. If it starts from A and it is moving like this, it reaches at B. What is the distance? Distance is the length of this path, so it is half of circumference. And what is the displacement? It is just this distance. How much it is? Actually, diameter 2r, because of this. If I say that the body has completed one full cycle, it returns A, B, A following this path. Distance is 2 pi r and displacement will be 0. So distance is the total length of the path covered, while displacement is the straight line distance of the final position from the starting position. So distance between a starting and final position, and this shortest distance is always a straight line distance. So we can say a straight line distance between initial and the final position, that is displacement. Now another very important example. Suppose I say the body starts from here, it goes up to B, say a distance of 1 kilometer, and then it goes to C, and this is 2 kilometers. what is distance and what is displacement. Distance is 3 km, 1 here and then 2 here. What about the displacement? This one, it is 1, but minus 1 is not, is actually the right answer because it has shifted left. So you will not say just 1 kilometer because 1 kilometer displacement will be for B. For this position C, it is to the left of the starting point. So we will say displacement is minus 1. It means it is to the left of the starting position. So it means displacement can be negative, but distance can never be. Distance is always positive. You are just calculating the total length of the path, right? But displacement can be minus, plus, can be 0 also, right? But distance cannot be. If you are moving, distance will never be 0. It will never be negative. Displacement can be 0. If you return to the starting point, it can be negative if you move in a direction opposite to the starting point. Okay. Giving you a problem, try it. Suppose there is a park and this is 40 meter, 40 meter, 40 meter. There is a gate here, you enter, then taking this path, you take exit from here. And this is entry. Now find out the distance and displacement. You take entry from this side and you move out from this side. It is a triangular park, 40 meter side. Each side is 40 meters. So find out the distance and displacement. So that's it. In next class we will be covering about we will cover speed, velocity and acceleration.